I'm Tomke. I'm a PhD student at PLEN, Copenhagen University. I'm from Germany, so I would speak in English to you. Yes, and I'm doing my PhD project about nitrogen use efficiency and how we can manage this better in our cropping systems. And today I want to talk about if conservation agriculture can close our nitrogen cycles in our cropping systems. Yes. So conservation agriculture mainly started after the Dust Bowl in the 1930s in the Great Plains in the USA, where there was huge sandstorms like this coming from wind erosion that we just heard about. So farmers started to stop plowing their fields to stop erosion. Then over the last 25 years, there was a rapid incline of conservation agriculture management here because it was soon clear that farmers could save money and diesel and time when they stopped using the plow. Today, around 11% of the arable cropland is managed after conservation agriculture principles. In the last years, it was also quite clear that there were climate change mitigation advantages because carbon can get sequestered, and because we use less diesel for the tractors, we also emit less CO2. In Denmark, the change happened a little bit later, but it's also increasing very much here. So over the last 2 years, around 26% of the area increased that is managed without a plow. But now you already hear a little bit, there is some confusion about conservation agriculture, not plowing, and so on. So I'll just quickly explain what conservation agriculture is. It has 3 pillars, and one is called minimum soil disturbance, which includes not using the plow. It also includes permanent soil cover. Here we see some nice cover crops. It also means that residues are left on the field. And it also includes a diverse crop rotation. Yes, but I want to talk about nitrogen. And why do I want to talk about nitrogen? This is a study made in 2015, which investigates 7 planetary boundaries. And what does that mean? So the idea is that our ecosystem has functions, and we need those functions to be able to continue living on this planet. And there are a few things that we do that bring the system out of balance. Climate change is one, and biodiversity loss is another one. And in the study, they investigated how much are we actually challenging the system, so it is still like how far can we go over the use, or how much can we actually pressure the system so that the ecosystem functioning is still in that we can live on this planet. And we can see here that for nitrogen and phosphorus, we are extremely challenging our systems, and we are already beyond the zone that we can actually allow. And then I have some maps here from Europe, where we see the distribution of nitrogen pollution in our systems. This is emissions to the air, mainly by nitrous oxide. And here we see losses to the aquatic system, which is mainly nitrate leaching. And we can see that it is quite highly correlated to intensive agricultural systems. So if we want to develop sustainable cropping systems, we have to close the nitrogen system, because obviously we need nitrogen to produce crops, but we have to stop losing this nitrogen from our systems. And how does this nitrogen actually move in an agroecosystem? There are mainly two cycles or circuits I'm focusing on. It's a big one here. I just talked about leaching. That is nitrate that is leached down beyond the root zone. We can use cover crops, for example, that are able to take up nitrate from deeper zones and bring it back up to the topsoil. But then we also have to consider the turnover in the soil up here, because the cover crops will die, and then the nitrogen is still bound into this organic material. And to be available for the crops later on, it has to be turned over. And conservation agriculture impacts both of these cycles or circuits. And I'm looking a little bit into these dynamics. So, can conservation agriculture promote opportunities to improve nitrogen cycling in agroecosystems? First of all, I already told you that cover crops are one of the main pillars of conservation agriculture. So, let's think a little bit about how cover crops should be designed to efficiently recycle this nitrogen. And is there something that happens to the soil structure that might impact nitrate leaching? We talked a lot about earthworms and big pores. Maybe the nitrogen leaches faster if it rains. That would be interesting to know. And then we have to talk about the topsoil changes, because if we drop the plow and we don't disturb the soil, the structure changes dramatically. So is the carbon content increased in conservation agriculture? And how does that impact the turnover of organic material? So this is a study made in the group where I'm doing my PhD in, and it investigates a lot of different cover crops. And we are a big fan of roots. So this is a root intensity profile. This is the topsoil, and we go down into 2 meters 50 depth. And this one here is a control. And then we have ryegrass here. Ryegrass has a lot of roots in the topsoil, but not really anything below 1 meter. And then I want to show you here dyer's vote, which has a lot of roots down to 2.5 meters. Then they also took soil nitrate in November to 2.5 meters depth. And we can see here that in the control, there is quite some nitrogen also in the lower layers. This is from the season before, but also up here. This has not been taken up by the crops. This has been taken up by the roots.
Could you tell me, dyer's vote, what is that in English?
It's It's a quite big plant. It's used for producing a dye earlier on, and it has flowers, nice flowers. But yeah, it's not so important what kind of plant it is. I just want to point you to the activity of the roots here. Yes, because then in May we see that there is high we see again that in the control the nitrogen that was up here leached down, so we have higher nitrate concentrations here. And in the topsoil we got some more nitrate that was turned over by microbes in spring, and we can see here that the dyer's vote that took up most nitrate here has a little bit higher concentrations up here. But the difference that we see here is not the difference that we see here. So dyer's vote took up more nitrogen that is available in spring. So not everything that the cover crops take up is actually then available. It's not like one-to-one we take up and then it's up in the topsoil. Yes. Okay. Let's look a little bit at nitrate leaching. These are samples that I took in the Grønne field trial over 6 different dates. And we have 4 different layers to 2 meters, and the colors show different tillage systems. We have a conventional tillage with a plow, a reduced tillage with a harrow, and CA, conservation agriculture, with direct sowing. And we see in these lower soil layers, in the subsoil, that the yellow bars are always a bit higher. That means there's more leached nitrate, but that might just be because the soil is more sandy in that field than in the other 2 fields. But what we don't really see is a big difference between the red and the blue, so between the plowed field and the not plowed field, the conservation tillage field. So, yeah, and we have to consider that there is quite some field variation. So they seem to be a little bit higher, but there's no significant difference that we can see. Yes. Okay, then I want to show you some organic carbon contents. Now we are up in the topsoil, and this is the organic carbon content I took in March this year. And for each tillage system, I took samples on 3 different fields. So it's an average on different fields. And we see that in the plowed field, we have a quite stable organic carbon content in the plow layer, and then below 30 centimeters, it's decreasing. And in the CA field, we see that there is more carbon in the topsoil, and then it's decreasing already, because the soil is not mixed and the residues are just coming from the top. So we don't see any increase in organic carbon content in the CA field. So what is this about carbon sequestration that everybody is talking about? There was a study made in Australia that showed that in all soils over the world, there's a very stable ratio in humus between carbon, nitrogen, phosphorus, and sulfur. That means when we want to build up humus and soil organic matter, we only talk about carbon all the time. We also have to talk about nitrogen, phosphorus, and sulfur, because otherwise the carbon will just be respired and can't be bound into organic matter. So maybe we should actually fertilize our humus. And of course, that would cost money, and there's a lot of regulations on nitrogen, but at least we should ask ourselves that question. Then I have some interesting findings here, and now we are also in the topsoil again, about the nitrogen. First, this is nitrate, and this is ammonium. It's both mineral nitrogen forms, and plants take up both. Nitrate moves in the soil and is leached out. Ammonium does not leach. It sticks to the soil particles. And we see that if we compare these 2 graphs, we see that the ratio between ammonium and nitrate is shifted in the CA. So we have a higher ammonium content compared to nitrate. And that's quite interesting if we talk about nitrate leaching and keeping nitrogen in the cycle. There are a few ideas why that could be the case, but we still don't really know. Then I also looked a little bit about the organic, the microbial community, and looking a little bit into the nitrogen turnover, because who's actually doing the job and what are they doing? So the organic matter turnover is mainly done by bacteria and fungi. In undisturbed conservation agricultural soil, people claim that there's more fungi compared to a plowed soil because the soil is not disturbed and fungi have mycelia and hyphae that are not disturbed. Then there's differences in temperature and water content in the soil, and that impact every biological activity. I did an experiment where I had soil from 3 different depths in 2 different, in the conservation agriculture soil and in the plowed soil here. And I took the soil and I gave it 23 different carbon sources. And then I measured respiration. And the idea is that if I have a diverse microbial community, I have more respiration from all 23 carbon sources. So the microbes are able to utilize all different kinds of carbon sources. And on the other hand, if I have, for example, a lot of bacteria on a plowed soil because they are able to utilize very fast and very efficiently, easily available carbon sources, then the respiration pattern of these 23 carbon sources would look different. And we can see here, no, we can't see here, but this is here's a bubble that shows the group of conservation agriculture bacteria. And so how we can read this graph is we have the community, the microbial community in the plowed soil here, which doesn't change with the depth. In the CA, it changes a lot with depth, and the first 5 centimeters are very different than the deeper ones. But we also see that the community in the CA soil is different to the plowed community. And then, I'm still analyzing these results. Trehalose, for example, seems to be closely related to fungi activity, which would support the idea that we have more fungi in the CA soils. Yes, but let's come back to my question. How should cover crops be designed? Well, they should have deep roots, they should grow fast, and they should have high nitrogen concentrations so they can be turned over fast. Does changing the soil structure impact nitrate leaching? Probably not. At least I can't really see anything. Is the organic carbon content increased in CA? No, it's redistributed. Is the turnover of organic matter different in conservation agriculture? Probably. We have a higher ammonium content, which is an indicator, and we have differences in the microbial respiration, which is also an indicator for that. That's that for now. I'm happy to hear questions.
Måske give en lille